am a member of BAE Systems Applied Intelligence, and I am a security consultant. And for the last couple of years, I've been largely focused in securing the transport industry. The transport industry for security consultants offers a really interesting challenge because we're seeing this merging of the information technology world and the operational technology world, where traditionally we would have systems where they needed simple binary on and off switches and systems in order to control them. We are now seeing them being connected to the internet, which is creating a myriad of challenges or interesting projects for us consultants. So there's two main technologies or technology trends across industries which are giving rise to such challenges. And they are the Internet of Things and also this increased big data processing. Now, through the use of big data processing in the transport industry, we can better understand the environment around us and hence create systems which are more intelligent, more efficient, and effectively more safe. And we harvest this big data through the use of the Internet of Things devices. Now, just for those who don't know, the Internet of Things is basically connecting endpoint devices, normally ones which just sense the environment around them, sometimes make small decisions or give small amounts of feedback, and sends this data to the cloud, the great internet. So one example that we know quite well is the smart fridge. The smart fridge, when you run out of milk, it recognizes that you've run out of milk using the sensors in it and will send a message to your online supermarket requesting more milk, which will then be delivered to your door. And I think that kind of summarizes the overall main aim of IoT devices, to kind of remove that friction between the human user and the device that we're seeing at the moment in our transport technology and in a lot of the ways that we interact with technology across all industries. So we're seeing this a lot in the IoT world and in the transport world. We're introducing IoT devices into the roadside to better understand when we can open the hard shoulder, better understand car flow rates so we know how to control traffic lights, and it's allowing us to make more intelligent systems. The difficulty that we're having, though, around securing these systems is that it is very hard for us to predict what kind of malware and what kind of challenges we will face in 20 years' time with these new devices. The issue with operational technology is often we install something into the roadside that we expect to be there for 20, maybe even 30 years. Those induction loops that we installed under the roads to detect car flow rates will probably be there until the roads get resurfaced. But how do we know what malware looks like in 30 years' time, or what the threats or who the attackers will be in 30 years' time? So how do we secure the systems that we make now so that they're secure for their whole life cycle? So I'm going to talk a little bit more about kind of IoTs, how they tie into transport systems and the challenges that they present. And also, hopefully, if I have enough time, some novel solutions that we're exploring at BAE in order to kind of beat the cyber trends that we're coming up against. So if you think about the autonomous vehicle, it is basically one large IoT device. It is taking in data from the world around it, understanding the world around it, and sending this data up to the cloud. That data is being processed along with other data, and then it is making decisions on where to go and what to do. We've seen a number of attacks on these kind of internet-connected devices, which means that it's very important, understandably, that we secure these systems. I mean, in the past, for example, the most common attack that we've had on Internet of Things devices is a piece of malware which is known as Mirai. Quite appropriately, Mirai is actually a Japanese word which means the future. Potentially because this is what attacks might continue to look like in the future. But the way Mirai works is it takes control of Internet of Things devices like the ones that you see on autonomous vehicles just by taking advantage of the fact that we do not change our default usernames or passwords. Mirai basically has a list of 60 default usernames and passwords, and when it detects an IoT device in its sphere, it tries to access it using those default usernames and passwords. Unfortunately, Mirai has been quite successful and has managed to take advantage of hundreds of thousands of devices across the world, Internet of Things devices. When a device gets infected with Mirai, you can't notice any difference. Maybe there'll be a small delay in its processing power, but that's about it. But what the attacker's actually done by taking control of all of these Internet of Things, low power, low intelligence, but easily to access devices, is the attacker has made basically a cyber army. He's made a huge army of processing power that he can use to gain access or to execute DDoS attacks on any system that he likes. The reason why we have to worry about securing IoT devices in autonomous vehicles is because we're also seeing this trend towards the weaponization of IoT devices. So your internet-connected printer, for example, one could gain access to that and take advantage of it and cause it to spew out thousands of papers in such a way that it causes the motor to overheat, set fire, and cause a small catastrophe in your office. I mean, that's quite a tenuous link, but you can imagine how easy it is for autonomous vehicles to gain control of them through these unsecured devices and cause quite catastrophic physical consequences. So it is very important that we secure these IoT devices, and there are some novel solutions coming out on how to secure them. If you look at securing IoTs, it's largely around securing the node and securing the link. So securing the IoT device itself and securing the communications link that sends the data to the cloud. And I think most of the interesting kind of advancements in technology that we're seeing are largely coming from that securing of that data link. There's two that we're seeing at the moment which I think are particularly interesting and could really change the way that we send data and process data in the future. The problem with the way that we send data at the moment is that encryption is extremely heavy. Encryption is basically a huge lock and chain around your data, which keeps it safe when it's in transmission. Unfortunately, though, hackers are getting more and more sophisticated, so we have to keep making this ball and chain of encryption heavier and heavier in order to prevent them from hacking into it. Unfortunately, though, with an autonomous vehicle, as you can imagine, we need that car system to be able to make decisions very quickly, within 0.3 seconds. So we can't have any latency in that transmission of data. So our standard methods of encryption that we're pursuing at the moment won't hold for much longer, given the requirements that we have in the autonomous vehicle world. One of the solutions is quantum encryption. So quantum encryption is a whole other talk for another time, but will basically allow us to, in a very lightweight way, secure that raw data and allow for a very secure, almost infinitely, in theory, secure transmission between the endpoint device, the autonomous vehicle, and the cloud. The second one, which I think is quite interesting, is through the use of artificial intelligence. So it's known as edge analytics. It's basically where in the device itself, there is some artificially intelligent processing power. And what this processing power does is it understands the data that's coming in, predicts what data it thinks should take place next, and then assesses what actual data comes in against its predictive model to see whether the car needs to brake or whether someone's jumped in front of the car or if anything is not going to plan. This means that the car itself can make decisions instead of the data needing to be sent to the cloud quickly, and it also means that the data that we then send to the cloud for further decision making is processed information, not raw data, and hence is a lot more lightweight than the data that we're currently sending. So as you can see from this kind of breakneck speed talk, there are a myriad of challenges that we're facing in the connected transport world. And a lot of it is around our challenges that we're facing at the moment in securing the legacy systems that we have of the past still on the roadside. We recognise that that's a challenge, and we've seen issues such as WannaCry, where outdated operating systems and unpatched operating systems have caused us no end of issues, and we're trying to think of the kind of new technologies that will still be valid and still be cutting edge for the next 30 years in order to mitigate those risks in the future. Thank you very much.